So section 1.8 is about simplifying expressions. One thing we got to learn is that in order for us to combine numbers, we know when to combine numbers that don't have letters, right? 8 plus 9, for example, we can do that. However, 4x, we're not going to be able to combine it with these other numbers because 4x does have a letter. So we're going to talk about in a little bit about like terms. So one thing that we're going to be able to do, only combine those that don't have a letter in this case. So the 4x have nothing with the other two numbers. So I'm going to finish this with 4x plus 17, right? 8 plus 9 is 17. I cannot combine those because both don't have a letter. So I'm just going to leave it at that. For my example being, we've talked about distributive property. I'm going to multiply the 4 to the terms on the inside. So I'm going to have 12m minus 8n. Because they have different letters, an M and an N, I'm not going to be able to combine them. I'm just going to leave it at that. For my example C, let me get rid of parentheses first. The 6 has nothing to do with parentheses, so please do not go 6 plus 3 to begin with. Leave the 6 alone. Remember that I'm going to get rid of parentheses, so I'm going to multiply the 3 to the inside. So I'm going to go plus 12k plus 15. Right? Once again, I multiply the 3 to the inside. I notice that 15 and 6 don't have a letter, so that is what we call like terms. So I'm going to finish this with 12k plus 21. Right? The 12k, I just copy it. 6 plus 15 gave me 21. Now here, once again, the 5 has nothing to do with the parentheses. This negative sign, I'm going to call it negative 1. So I'm going to multiply it to the inside. So negative 1 times 2y, I'm going to call this negative 2y. Negative 1 times negative 8, I'm going to call this plus 8. When it comes to letters, I only have the negative 2y. But when it comes with numbers that don't have a letter, I have 5 plus 8. So I'm going to call that 13. A term. One thing before we continue, let's talk about some vocabulary here. A term is a number, a variable or a product or quotient of a number in one or more variables raised to powers. Example of terms include 9x, 15y squared, a negative 3, a negative 8m squared n, 2 over p, and k. All these are examples of terms. Notice how I don't have pluses or minus in there. I have negative signs, but once again, I do not have any plus or minus between them. It's fine if it's just a number. Negative 3 technically that's just a number. It's fine if it's just a number. It's fine if it's a number in a letter. It's fine if it's a number in a bunch of letters. So as long as you don't have plus or minus in between them, that is what we call terms. Once you put a plus or minus in the expression, that's where we're going to start separating terms. One expression could have multiple terms. As an example, 5x plus 3. I have two terms. 5x is one term, 3 is another term. Once again, terms are separated with a plus or minus sign. Negatives, it's fine, but once again, terms are separated with a plus or minus signs. Each term has a number, including this k here by itself. Every term has a number. If you don't see a number to begin with, like I said, that one for example, it is the number 1. But every term has a number, and that's what we call coefficient. So here, the numerical coefficients of the terms shown above are 9, you guys can see my 9, 15, negative 3, negative 8, 2, and 1. So once again, the numbered is what we call coefficient. All right, now that we said that, let's move on. Things on your homework are going to be give the numerical coefficient of each term. Remember, you're looking at the number in front of the question. So here it is, positive 15. Well, my example is a negative 2. And I said the number in front of the term. This 3, that's not a coefficient. I know that's a number, but that's an exponent, or some people call it power. So that's not a coefficient. So that's why I did not call it 3. I called it negative 2. Now it says here, combine like terms in each expression. Terms or like terms are those terms that have the same letter with the same exponent. So for my example 8, both have an M, so I'm just going to combine, the way we combine like terms, we just add the coefficients. So here I'm going -9 plus 5. I'm going to call that -4. Remember, they have different signs. We subtract, keep the sign of the large one. So this is -4m. I'm just going to copy the m, so it's going to be -4m. Don't do anything to the m other than copying it. The reason why the m is there is just for us to know what can we combine with. This thing just froze for a minute, so I'm just going to wait on it. But once again, the letters do not change the letters. The letters are there just for us to know what goes with what. So my answer should be -4m. Here from example B, all of these are R, so I'm gonna just add my numbers. 6, remember my coefficient, 6 plus 3, that's 9, and 9 plus 2, that's 11. So I'm gonna call this 11R. That's what we call combining like terms. Here, technically in front of this last x, there's a 1 in front of it. Do write it if you need to. So 4x plus 1x, I'm just gonna call this 5x. And here in this one, notice how my y, they have a y to the second power, but it's still the same y to the second power. So I'm just going to look at my coefficients. 16 minus 9, I'm going to call that 7y squared. Now for my last example, I'm just going to call this 32y plus 10y squared. Notice I'm not going to do anything. And the reason why, because my y's are different. One y is y to the 1. Technically, we don't see an exponent is y to the 1. And the other one is y to the second. So it is not the same y. They have different exponents. In order for me to combine them, they must have the same y. So, or better said, the same letter. Now let's simplify a few expressions here. Here, let me get rid of parentheses. I'm going to multiply that 2 to the inside. The 14y has nothing to do with parentheses, so I'm just going to copy it. Now, positive 2 times 6, I'm going to call this 12, positive 12. Then 2 times 3y, I'm going to call this 6y. I notice I can combine the y's. 14 plus 6, I'm going to end up calling this 20y plus 12. Now let's take a look at my example B. 9k has nothing to do with parentheses. Minus 6 has nothing to do with parentheses. Now this minus 3, if you guys want to call it minus 3 or -3, it's next to parentheses, so I'm just going to multiply it in. -3 times 2, I'm going to call that -6. -3 times -5k, I'm going to call this positive 15k. Remember, negative times a negative equals positive. And I know we talked about in subtraction, I'm going to change this to plus, change the sign that comes after. Let me change this to plus, change the sign that comes after. So now looking at those that have a k, I have 9k plus 15k. I'm going to call that 24k. Right? I'm just going to add the k's. The coefficients. And then on those that don't have a letter, notice how I cross them out. That way I know I already used them. Now here, -6 plus a -6, I'm going to call that -12 or -12. So those are basically my answers for those two. Lastly, let's see. Write the phrase as a mathematical expression using x as a variable and simplify. Oh, I don't have a question there. Hold on, let me add the question. So now the question is 3 times a number. Remember, we're going to use x as the variable. So let me read this little by little. 3 times a number. So I'm just going to go 3 times x. Subtracted from, remember the word from, when it comes to subtraction, we're going to do a minus, but instead of putting it after 3x, we're going to put it before 3x. Subtracted from. So before the minus sign, we're going to write the sum of a numbered in 8. So let me just write that. The sum of a numbered in 8. Okay. So technically, we have a 1 in front of the parentheses. Let me get rid of parentheses. Let me multiply the 1 from the outside to the terms on the inside. So I have 1 times x, 1 times 8 minus 3x. I'm just going to finish this as negative 2x plus 8. Notice I just combined my x's. Like I added the coefficients. 1 minus 3 gave me negative 2, and then my plus 8. Looking at my second example, let me read this little by little. Twice a number, so let me go twice a number. Remember, twice means times 2. Added to, so added to the sum of 6 and the number. So we're going to add it to the sum of 6 and a number, or better yet, the sum of 6 and the number. Okay, so let me multiply the 1 outside of the parentheses to the inside. 1 times 6, 1 times x, plus 2x. I'm just going to end up calling this 3x plus 6. I combined my x's. 1 plus 2 gave me 3. Your question might be, well, do I have to write the one with the letter first? Do I have to write the other number first? Like, what do I have to do? As long as both of them are there, the order does not matter. So mathematically, they're both correct. So instead of 3x plus 6, you guys were to write 6 plus 3x. Mathematically, they're both correct. It's just that we like, when I say we, mathematicians, we like to write them in order from the highest exponent. So those that have a letter, if there's multiple terms that have a letter, the one with the highest exponent first, and then we just go down. That's how we like it. But on the quiz or test, I don't mind how you write it. So mathematically, they're both correct. It's just that we like to write the one with the letter first.